5.7 picks up where we left off, and now we're going to talk about how to find roots in a more complete format. All right, so suppose you have a function, a polynomial, p of x. All right? Now, suppose there's this number c that's a 0 of p of x. So suppose 3 is a 0, okay, of this function. We also say that c is a root or it's a solution of p of x, right? They are synonyms. We're just reiterating that. So either it's a 0, a root, a solution. You can also say that that point is an x-intercept of the graph, okay? But there is one other thing that we've touched on, and now we're just going to say it one more time just to recall. If c is a solution, then x minus c is a factor, all right? So let's take an example. Suppose you have this function, this polynomial, p of x, all right? -3 is a solution of this. Well, that means that x minus -3 or x plus 3 is a factor. Similarly, 2 is a solution of that polynomial. Well, that means x minus 2 is a factor, right? You can keep going. 1 is a solution. That means x minus 1 is a factor. You get the idea? So we're going to work with this idea in this section. We're going to come back to that in a little bit.
That was number 29.
Yes, it was number 29. That's why 29 was assigned. Yes. So let's solve this one and see how many and what type of solutions there are. All right. Is there a possibility to, can we factor this?
Yeah.
Yes, right? So how does that factor? What two numbers add up to 2 but multiply to -48? 8 and 6. So x plus 8, x minus 6. That would mean that x equals -8 and positive 6. Okay? So how many solutions to this? 2. And are they real, imaginary, what?
Real.
They are 2 real. All right? Well, let's take a look at this one. This is x to the 4 minus 256. Is there any way to factor this one? 256 is this is a perfect square, right? It's what squared? 16 squared. And x to the 4 is a perfect square. So I can write this as x squared minus 16, x squared plus 16. And you can factor the first one further. Difference of 2 squares, x minus 4, x plus 4. Well, what about the next one? No, because it's a difference of 2 squares, and this has a plus sign, so that doesn't work. So we just leave it as is. Now, the first one, the first factor gives me a 0 of x equals 4. What about the second factor? X equals -4. Here, right, x squared plus 16 equals 0. X squared equals what? -16. And now when I take a square root of both sides, x is equal to not 4i. Just 4i? What about plus or minus 4i? Plus or minus 4i, right? Now, how many total solutions here? 3? 1, 2, 3, and 4. Positive 4i, negative 4i, positive 4, negative 4. So there are 4 total zeros. What are their types? 2 real, 2 imaginary. So here we have 2 real and 2 imaginary. So how many total? 4 total. And how many total for the first one? 2 total. So now, what's the degree of that first one? 2. What's the degree of that? 4. So what do you notice?
Whatever the highest degree is the
number of solutions. So that brings us to The fundamental theorem of algebra. Okay, so if it's called the fundamental theorem of algebra, you know it's got to say something good. Well, it says that every polynomial, okay, that's got a degree of 0 or more has got to have at least one solution. So there is no way. So scratch out, okay, throw away that concept of, oh, no solution. No, every single polynomial has got to have at least one solution. What's more, if a polynomial has a degree of n, then it has exactly n roots, okay, which you just came up with all on your own. So now, is there any way we could figure out more information about what type of roots? Well, huh? So discriminant. All right, so here's Descartes' rule of signs. Descartes was the French mathematician / philosopher to whom we owe the Cartesian coordinate system with x and y.
No way.
Cartesian, Descartes, he's the guy who said, I think, therefore I am. He's the guy who said that. Okay, so he has a way for us to figure out how many positive solutions something has and how many negative solutions something has. So, what Descartes' rule of sign says is it tells us how many possible positive zeros will be and how many negative zeros will be. So what you do, we can read this on and on and on. It will not do us any good until we actually do an example. So let's do an example. What you do is this. First, we have to figure out the maximum number of positive roots. So you take your p of x, you take your polynomial, you have to go down the polynomial horizontally, and you have to see how many times the coefficients change between positive and negative, okay? So here we have negative x to the 6, then we have a positive 4, then we have a negative, so that's twice that the signs changed, right? So the maximum number of positive roots is 2.
Just with the x.
Right. Or now you take this maximum number and you keep subtracting 2's from it. Why 2? Because that's what Descartes said. If we ever run into him one time, we'll ask him why it's 2, but for now it's 2. So it's 2, or if you subtract 2 from this number, what do you get? 0. Now, suppose when we counted the number of sign changes, we didn't get 2. Suppose we got 4. What do we do then? Well, 4 minus 2 is 2. So it'd be 4 or 2 or 0. Suppose when we did the changes, we got 5. It would be 5 or 3 or 1. When you can no longer subtract 2, when you don't have enough numbers to take away 2, you stop. Okay? All right. Next, so this is the maximum number of positive. What about the number of negative roots? Well, for that, we have to take p of negative x. What does that mean? We have to take every single x and make it a negative x. So it'll be negative x to the 6 plus 4 negative x to the 3 minus 2 negative x to the 2 minus negative x, and I'm only going to do it in this much detail this one time because now we're going to figure out how to do it quickly. One sec. So here, is this term going to end up as positive or negative at the end of the day? That first one. Okay, so negative, the red one will be positive, but there is a purple negative out front, so it's negative x to the 6. Okay? Here. Okay, so negative x, what's negative x to the 6? Positive x to the 6, right? Right, because negative to the... Negative x to the power of 6, just the red one here, just this, will be positive x to the 6. Combined with the purple negative out front, it'll be negative x to the 6. All right, so minus 4x cubed here. Now here, the negative x squared will become positive, so it's negative 2x squared plus x minus 1. So this is p of negative x. In order to save us some time next time, let's just compare this with the original, okay? Look at the first term, negative x to the 6, negative x to the 6. Did anything change? No. 4x cubed, negative 4x cubed. Did anything change? Yes, that one changed. Negative 2x squared, negative 2x squared, same. Negative x, positive x, that one changed. So for next time, when you have to find p of negative x, all right, what does the exponent have to look like for it to flip sign? It has to be odd for it to flip sign. Okay, so next time we could do it quicker.
So all the odd exponents flip side.
Yes.
Wouldn't the negative one be positive one?
No, because we're not changing that one.
Why would it be?
Because there is no x there to change.
You only do that.
Yes. Okay, now we have to do the same thing. We have to go horizontally and see where the coefficients change sign. So we have minus, 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 plus, and then back to minus. So how many times was there a sign change? Twice. So this is the number of negative zeros, 2 or 0. Okay, now we have to make a chart. So for the number of positive ones, we got either 2 or 0. For the number of negative ones, we got either 2 or 0.
I don't understand like or
You take the highest number, the 2, and now you have to keep subtracting 2's from it.
Right.
Okay? So when I get my initial 2, I just do minus 2 and I get 0.
Wait, why is the highest? What do you mean the highest number is 2?
So now we need to make a chart of the number of positive, negative, or imaginary roots. What we have to do here is we have to come up with all of the different combinations. All right? So what I do is I take this 2 on top and I have to match it with each number on the bottom. All right? So it's going to be a positive 2 with a 2 or a 2 with a 0. I take this number and I have to match it with this, so 2 with 2 or 2 with 0. Now I take the 0 and I match it with what?
0 or
2 or 0.
So
So now I take this 0 and I match it with 2, or I take the 0 or I match it with 0. Okay, now, remember, okay, so what is the degree of this function? The degree of this function is 6. So how many total solutions should there be? 6. Okay, so now we have to complete this last column so that each row adds up to 6. Okay, so now if I get 2 positive solutions and 2 negative solutions, how much room do I have for imaginary? 2. If I get 2 positive and 0 negative, how much room for imaginary? 4. 0 positive, 2 negative, how much room for imaginary? And lastly, how much room for imaginary? 6. Now, imaginary numbers always come in what? Remember? Imaginary numbers always come in pairs. So this column must always be even. Because I can never get 5 imaginary numbers or 3. It's either 0, 2, 4, 6, and so on. Okay. I'm going to do one more with Descartes' rule and then take questions on Descartes' rule. Yeah. Number of positive zeros, okay? there is one change there, and there is one change there. So there are two total places where it changes sign, 2 or 0. Now I need to take h of negative x. And I'm going to do this the quicker way. So I'm going to look at my function and just flip the sign of the ones with odd exponents. So this one, and this one. The rest stay the same. So it's negative 2x to the 5th, positive x to the 4, minus 3x cubed, minus 4x squared, x plus 9. Okay? How many times does this change sign? 1, 2, and 3. So for the number of negative, it's 3 or 1. Okay.
Why 1?
Because 3 minus 2 is 1. Right? So you take this number and you do minus 2 and you get 1. Okay. So now, positive, negative, imaginary. Okay? So we have to match. This is not match. Okay. So we're going to match now. 2 with 3 or 2 with what? 1. And then we're going to match 0 with 3 or 0 with 1. All right, what's the total supposed to add up to? 5 in each row. So for the first case, we can't get any imaginary. How many imaginary here? 2, 2, and 4. All right? That's it. Okay. So now, how to actually find this? The middle two are not the same. Okay. Uh-huh. Sometimes. Okay. So now how to find the zeros. All right. We're going to use Descartes' rule of signs to find the number and the type of roots first of all. Okay. So the number of positive zeros, there is 1 here, 1 there. So 2 or what? 0. All right, now let's do f of negative x. Negative x cubed minus x squared minus 2x plus 4. So how many times does this change sign? Just 1. All right, so let's do positive, negative, imaginary.
You don't do an OR when it's just 1?
No, there is nothing to subtract from. Okay? So this is actually a simpler case because the 2 matches only with the 1, and then the 0 matches with the 1. All right? So if I have 3 here, how many total for imaginary? 0. And here, 2. All right, so those are all the possibilities.
How do you know what you need for the imaginary?
It's the degree. Okay.
Are you done with the problem once you make this part?
We're just starting the problem now. Okay. So now it says use a table of values to find any real roots. Let's put this in the calculator. So we have x cubed minus x squared plus 2x plus 4. Okay.
You put in the first one where you haven't touched.
Okay. So wait a minute. I don't want to do this. I wanted to look at the table. So go to the table. Now, at the solution, right? So if you have a solution, second graph gives you the table. Now, if you have solutions, right? Suppose this is a solution, and that's a solution. At each of these solutions, what's the y value? right, 0. So if this is x equals 3, y equals 0. Suppose this is x equals 1, y equals 0. So at each of the solutions, y equals 0. So we're going to scroll through this and see where we have 0 values for y. You see there is one for x equals -1. Are there any others? Well, there are no others, right? Okay, so
Does it go on forever? Can you go on to the very top?
at x equals -1, at x equals -1, there is a 0. Okay, so what does the chart tell us? The chart tells us there is definitely, in whatever the case may be, there is definitely one negative. And look, x equals -1. Yeah, that's a negative solution. Now, there could either be, this says, there could either be 2 positive or 0 positive. Well, we didn't find any other zeros in the table, so it must be that there are no more positive ones, but now there are going to be 2 imaginary ones. Okay? So let's do that. Once we have our first 0, we can do synthetic division just like we did before with our original function. 1, -1, 2, and 4. Okay? 1 comes down, -1, -2, 2, 4, -4, 0. Okay? All right, so here, from this, what are we going to get? Well, x plus 1 first, then x squared minus 2x plus 4 equals 0. Okay? All right, this can't be factored, so I have to use the quadratic formula on this. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2. So x equals 2 plus or minus the square root of 4 minus 16, -12 over 2. Okay, so 2 plus or minus. An I is going to come out. And what does root 12 simplify to? 2 root 3 all over 2. So this is going to be 1 plus or minus I root 3. So finally, what are my zeros? X equals -1 and x equals 1 plus or minus I root 3. Okay? All right. Now, okay, so let's talk about complex conjugates. A complex conjugate is sort of like a partner for your complex numbers. Remember, I always say complex numbers, imaginary numbers always come in pairs. So if a plus bi is a solution to something, then you take the imaginary part, flip the sign, and it becomes a minus bi, and that's a complex conjugate. Okay, so what does all that mean? If I have 3 plus 2i, I take the imaginary part, 2i, flip the sign, what does this turn into? 3 minus 2i, that's the complex conjugate. So if I have 2 minus 7i, what's the complex conjugate? So if I have -5i, what's the complex conjugate? 5i, right? Okay. No, it's -5 times root minus 1. It's different. Okay. Now, here we have to go backwards. We have to write a polynomial function. Until now, they gave us polynomials and we had to get the zeros. Now, they're giving us zeros. We have to go backwards and find the function. Okay? So literally like press the rewind button. Okay, so the zeros of this are 4 and -i. But -i can't exist on its own. There is also its complex conjugate, which would be I. That's always on you. Okay? They give you one, you have to find the other one. Okay, now. No. Okay. So remember, I am she. Okay, so remember how we said if 4 is a 0, then x minus 4 is a factor? Well, if negative I is a 0, then what's a factor? X plus I. If I is a factor, then if I is a 0, then x minus I is a factor. And I call this f of x, or p of x, or h of x. Now I need to multiply all these out. Now, you could do it in any order. The best way, the most efficient way, is to let go of the x minus 4 for a little bit and to combine ones that are most similar to each other first. So, can I multiply this? I can definitely do first, outer, inner, last. However, if I have this pattern, x plus something, x minus something, what's the quick way? You square the first, you square the last, and you put a minus in the middle. So let's square the first, let's square the last, and let's put a minus in the middle. Easy as pie, or easy as I. Okay, that's a new one. I've never used that one before. X squared plus 1, or easy as I. Okay, so x squared plus 1. Now can I FOIL this one? Yeah. I sure can. So first terms give me x cubed. Outer terms plus x. Inner terms minus 4x squared. Last terms minus 4. Oh my god. So this is f of x equal to, you've got to put it in the right order. Of course. There you have it. Look at that. Look at that. All you had was 4 and negative I, and look at the function that you came up with. That alone deserves a standing ovation if you ask me. Okay, so this homework is due tomorrow. All of it is due tomorrow.